This video will introduce the topic of quadratic models and applications. The learning outcomes for this topic are to solve for a specific variable in a quadratic equation and to solve quadratic equations using applications and models. Let's begin with solving for a specific variable in a linear equation. Recall that we did this in Unit 1, and an example we did was solving for y in the equation ax plus by is equal to c. In this situation, as well as in the ones that we will see in this unit, treat all other variables or letters as if they were constants or numbers and solve for this specific variable. Let's try an example. Let's say we have the area of a circle formula, a is equal to pi r squared, and we want to solve for r, the radius. First, we would divide both sides by pi and get a over pi is equal to r squared. Now we can use the square root property and take the square root of both sides and get r is equal to plus or minus the square root of a over pi. Remember that this is the same as r is equal to plus or minus the square root of a over the square root of pi, which means that we will need to rationalize the denominator. So we multiply our fraction by the square root of pi over the square root of pi and get r is equal to plus or minus the square root of a times pi over pi. This rationalizes the denominator for our fraction. The second learning outcome is to solve quadratic equations that are used in applications and models. The biggest difference between applications and models is what is given in the problem. If you are working on an application problem, you will be required to come up with an equation given the situation of the problem. In our case, you will be creating a quadratic equation for the problem. One thing that may help you with application problems is to review how to convert words into math. I have provided a video, Translating English into Math, that you may find helpful. If you are working a model problem, a quadratic equation will be supplied and you have to use it to answer the questions. Let's take a look at each type of application problem you will encounter in the example videos and in the homework. The first type of problem will be dealing with volume of an open box, a box without a lid. Recall that the volume of a box is V is equal to length times width times height. The way the box is created is by cutting the same size squares from each corner of the sheet, then folding the flaps upward along the dashed lines, such that the length and width of the box are these dimensions of the dashed rectangle, and the height of the box is the length of one side of the square. Another application problem you will encounter is using the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Remember that a and b are the lengths of the sides of the right triangle, and c is the length of the hypotenuse, which is directly across from the right angle of the triangle. Finally, the third type of application problem is about physics, and in particularly the height of a projectile in one dimension. This type of problem is used in many math classes, so you may want to make sure you understand this type of problem. In physics, we know that the height of a projectile that is thrown vertically upward can be modeled by the equation h of t is equal to 1/2 a t squared plus v naught t plus h naught. I use the word naught after the letters v and h to indicate that these values occur when t is equal to 0. In our formula, h of t is the height of the object at some time t, after it is thrown or dropped. A is the acceleration due to gravity, v naught is the initial velocity that the object is thrown, and h naught is the initial height of the object before it is thrown. Let's see some examples on how to use this physics equation. If a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, let's find its height function s, which will be in feet, above the ground t seconds after the projectile is launched. Let's begin with our equation s of t is equal to 1/2 a t squared plus v naught t plus h naught, and substitute what we are given. Since this launch is taking place on Earth and the units being used are feet, acceleration, a, is equal to -32 feet per second squared. This represents the acceleration due to gravity on Earth. It is negative since we are considering that the upward direction is positive and gravity is pulling the object down. in the negative direction. We are told that the initial velocity upward is 100 feet per second, so this is v0 in our formula. Finally, we need the initial height h0 of the projectile. Since the projectile is launched from the ground, h0 is equal to 0. This results in the following equation of s of t, which is the same thing as h of t, is equal to 1/2 times negative 32 times t squared plus 100t plus 0, or s of t is equal to negative 16t squared plus 100t. Let's try another problem. A ball is projected directly upward from an initial height of 100 meters with an initial velocity of 100 meters per second. Again, we start with our formula for projectiles. S of t is equal to 1/2 at squared plus v0 t plus h0. Let's believe that this ball is being thrown here on Earth, and meters are being used, so acceleration, a, is equal to negative 9.8 meters per second squared. v0 is 80 meters per second, and h0 is 100 meters. Paying attention to units also helps us decide what information is given. Height will have units of distance, such as meters or feet, while velocity will have the units of meters per second or feet per second. Substituting our given information into our equation, we now have s of t is equal to negative 4.9 t squared plus 80t. Now that we know how to create equations to model projectiles, we will be asked to use them to find when does the projectile hit the ground. Remember that this means that s of t will equal to 0. This will lead you to solve your quadratic equation using the methods we discussed earlier in this unit. Another popular question to ask is when will the object reach its greatest height? Essentially, the question is asking for the vertex of your quadratic equation. We can find this two different ways. One way is to change our quadratic equation into vertex form using completing the square. The other way, the preferred way, is by using your knowledge of graphing quadratic equations. Remember that the vertex occurs on the axis of symmetry, and we can find the AOS quickly by using the fact that the AOS is x is equal to negative b over 2a. For our formula, it will be t is equal to negative b over 2a. This will answer the when question, as t represents time. Plug this t value into the original quadratic equation we created to find the maximum height that the object will reach. Remember that application problems will ask you to create an equation to represent a particular situation, whether it is volume of a box, finding lengths of a right triangle, or the height of a projectile. Model problems will give you the equation that can be used to model the behavior of a particular situation. You will be asked to use this given equation by either inserting a value for the independent variable, x, and finding the result, y, or vice versa, insert a y value and solve for the x values. I know this will be a trying topic for many of you. Please use resources available to you to do the best on these problems. This concludes this video.